We are on multiple choice question topic 1 review. This is on limits, continuity, and differentiability. First of all, let's talk about limits. So the limit as x approaches a of a function is equal to a number if and only if the limit from the left of that number is equal to the limit from the right of that number. So remember, the limit from the left has to equal the limit from the right for this limit to exist. We do not care what is happening right at that x value, only the limit from the left and right. F has a horizontal asymptote if the limit as x goes to infinity is that number. So, and that makes sense. As x goes to infinity, if y is approaching some number, then that would be a horizontal asymptote. It's the definition of a horizontal asymptote. Same thing with x approaching negative infinity. You can have that as well. Okay. F has a jump discontinuity if the two limits are not equal. So the limit from the left is not equal to the limit from the right. There's a jump in there. That's called a jump discontinuity. F has a removable discontinuity if the two limits are equal, but the value of the function is not equal to the value of the limits. So that would be a hole. Maybe the actual value would be up high, down low, whatever, or just not even there. That's a jump discontinuity. There are 3 reasons a function is not differentiable or can be not differentiable at a value of x. So f has a vertical tangent, f has a discontinuity, or f has a cusp. Okay, so f is not differentiable at x equals a if f has a cusp. So you can say that f prime does not exist if f has a cusp. Be sure to keep that straight. A cusp is when the slope from the left does not equal the slope from the right. Let's look at some examples, multiple choice examples. So here they're just asking what is the limit as x approaches 2. So limit as x approaches 2, I see that 2 is a cutoff. So I would just put 2 in for, I'm taking the limit from the left and seeing if it's equal to the limit from the right. So, but multiple choice form, we don't have to show all of that work. If it was an FRQ, I would write that out. The limit as x approaches 2 from the left is equal to whatever. So I would write that all out. But here, I would just plug in 2 for x and see, is that equal to plugging in 2 for x down below. So at first glance you might say, no, there's no way those are equal to, but remember our log properties. This is 1/2 natural log of 16. We can move that coefficient to the exponent on the 16, make that the square root of 16, which is 4, and we can move this to the exponent on the 2, that's ln of 4 as well. Both of those are equal, so that is the limit. Okay. Number 2 here. For what values of x is g not differentiable? So let's just go down the line here. Let's see. At -4, when x is -4, we have a cusp. So -4 makes g not differentiable. So, but that doesn't narrow things down. Let's keep on going. -3 is another cusp. So a does not have a -3, so I'm going to get rid of it. The other 3 do. Some kids like to think that there's something funny going on here. That's just a horizontal tangent line. The derivative is 0. That means it exists. If the derivative is 0, it exists. So -1 is not an answer here, so I can get rid of C. Right here at x is equal to 1, we have a vertical tangent line. So when x is equal to 1, we need to have a discontinuity, a point where g is not differentiable. So the answer there is B. Okay, which of the following limits are equal to 0? So each of these I notice is x going to infinity, so we're going to apply that process. This doesn't matter. As x goes to infinity, that doesn't matter. I reduce what's left, and that reduces to 5/3. And that's not 0. Here, the 4x minus 10 won't matter, the 3x won't matter, and this reduces to 5/3x. Then let x go to infinity, and we get 0. So 2 is an answer. As x goes to infinity, doesn't matter, doesn't matter. This reduces to 5x/3, and as x goes to infinity, that's infinity, which is not 0. So the only answer there is the number 2 there. Okay. Number 4. Which of the following statements has a horizontal asymptote of y equals 3? Well, when I see horizontal asymptote, I want to that means limit as x goes to infinity or negative infinity, plus or minus infinity. So I'm taking these and taking the limit as x goes to infinity. As x goes to infinity, these won't matter. Reduce what's left. That's a -3. That's not 3. So not 1. The limit here, as x goes to infinity, would be infinity. So not 2. The only answer that could be there is 3. So B. And the limit as x goes to infinity here is indeed 3, by the way. Okay. For what values of k is h continuous? Well, the only value of x that's in question is 3. So I'm going to put 3 in for x and put 3 in for x and see what value of k makes them equal. So 9k will be 13. K is 13/9. Okay, number 6, this limit. Well, if we just plug in 4, we get 0/0. That's a L'Hopital's form, so I'm going to use L'Hopital's. I'm going to take the derivative of the top is 1, the derivative of the bottom is 3x squared, and I'm taking that limit. For multiple choice, I usually don't write all that work. I just do that. We don't have to write it out for multiple choice. But this would be 1/3 times 16. 1/48. Okay, which of the following is equivalent to pi/2? Pi/2. So, I see these, I see the arctans. Which of those is pi/2? This is one that I need you to know. We've been doing this since the very beginning of school. I need you to know that the limit as pi goes to infinity of arctan is pi/2. My rationale for that is the graph of tangent, just one leg of the graph of tangent does that. Just one leg. Arctan is when it's the inverse function, so we switch the x's and the y's. Essentially, we're switching the x's and the y's. So it says as x goes to infinity, well, that says y goes to infinity of this guy. And as y goes to infinity, x is going to pi/2. As y goes to negative infinity, x is going to negative pi/2. So this would be a negative pi/2 over here. And then here, my thought process is a little different. Okay, as x goes to 0, I know what our cosine of 0 is, and that is pi/2 because cosine of pi/2 is 0. That's my thought process. Okay, I could have used that same thought process here. Tangent of what is pi/2? Tangent of what is infinity? Okay, well, tangent of pi/2 is that asymptote. That's why I don't usually go that route. But anyway, the answer is 2 and 3. See? Okay, number 8 here. The graph of this has, and then they have some different things going on. Well, first of all, I know it's not a horizontal asymptote because the limit as x goes to infinity is not 0. The rest of it deals with x is equal to 2, and that makes me want to factor this. So I'm going to factor this. On top, I'm factoring out an x. On the bottom, that's just a difference of squares. On top, I can factor a little bit further. And I see that we have a hole at x is equal to 2. That is a removable discontinuity. An infinite discontinuity is an x value that makes a vertical asymptote. That's an infinite discontinuity. Okay, FYI. All right, so essentially A and D would be similar to each other. Okay. All right, number 9. Which of the following statements is true? The limit exists, h of negative 2 exists, h is continuous at x is equal to negative 2. So, when x is negative 2, I can put it in there and I get a number. So I know that h of negative 2 exists. What number do I get? Let's put it in and see, because we're going to need that for our continuity thing. So if I put negative 2 in for x, I get a 4 plus 4 minus 20. That's a negative 12. Okay? Now, does the limit as x approaches negative 2 exist? For that one, we're looking at this, because remember, the limit is not when it's equal to, it's when it's not equal to, but getting close. So essentially, we want to take the limit of this guy. So the limit as x approaches negative 2 of that. So if I put in negative 2, I get 12 minus 12. I get 0 over 0, so I'm going to use L'Hopital's. Derivative of the top, derivative of the bottom. Now plug in. We get negative 12. So, negative 12. Okay. And so the limit does indeed exist. Yes, it does exist. Is h continuous? Well, h is continuous if the limit from the left is equal to the limit from the right, which is equal to the function value. And since we got the same values here, we are continuous, so the answer is D, all of them. All right, a couple more here. Number 10, if f is continuous on the closed interval, oh, this is written a little bit wrong. I need to fix this. But anyway, on the closed interval from in between A and B. Okay, and this is true. So f of A is less than f of B. Which of the following must be true? Okay, so I know that f of A is less than f of B. And we're continuous. All right. There exists a number C between A and B such that the y value is between A and B. Well, no, not necessarily. Not necessarily. The y value doesn't have to be between A and B. These are x values, right? So not necessarily. There exists a number C between A and B such that the y value is between these two y values. Yes, that's the IVT. That's intermediate value theorem right there. So the other two, for similar reasons, don't make any sense. Okay, mental note for me to go back and fix that. Okay, if the function f is continuous at x equals 3, which of the following must be true? Which of the following must be true? The function value is less than the limit? No, the function value has to be equal to the limit. The limit from the left is not equal to the limit from the right? No, they have to be equal. Everything has to be equal there. The derivative exists. If f is continuous, does that mean the derivative exists? No, we might have a cusp. And then that leaves this, which is the definition of differentiability at x equals 3. Next up, let f be defined by this function. Which of the following statements is true? Okay, and we're dealing with differentiability, continuity, a limit. So it would be nice if we knew what the graph of that looked like. So let's sketch this graph. When x is 2, we're at 0. When x is 1, we're at the absolute value of -1, which is 1. When x is 3, we're at the square root of 1, which is 1. When x is, what's the next convenient number? Maybe 6. When x is 6, we have the absolute value of 4, which is 2. When x is this far away, 1, 2, 3, 4, we're up at this 2. So we're getting this kind of thing. So we are continuous, but not differentiable at x is equal to 2. A. That's a really quick review of limits, continuity, and differentiability. They can ask a lot of questions. They can ask confusing questions, but try to keep everything organized in your head. All right, I'm going to make a note to fix that error, and I will post the correction. Okay.